All right, so problem 8, we have that we want a 90% confidence interval for the average amount spent on books by freshmen in their first year at a major university. The interval is to have a margin of error of $2, and based on last year's sales, we estimate that the standard deviation of the amount spent will be close to $30. The number of observations required is closest to, okay, so for this, let's first start off by writing just the general form of the confidence interval for estimating population mean. That'll be x bar plus or minus t star times the standard deviation of the sample over the square root of n. And let's remember that x bar is our point estimate, and this whole portion is the margin of error. So we want this part of the equation to be $2. $2 or less is what, just again, always want the most $2, but less than $2 is better. And so we have to basically figure out what the value of n will be if we're going to make this whole quantity equal to 2. So let's make it, if we're going to make the margin of error equal to 2, we would set this, all of this, and figure out what t star, the sample standard deviation, and ultimately what n would be. Now, let's look at what we're given. We're given that we want a 90% confidence interval, so that's going to allow us to find t star, but the problem is that for t star, you would need to find the, you would need a sample size defined. You would need to have n array defined, but that's what we're ultimately trying to figure out. So we're not going to have we're not going to have t star. In this case, we're just going to rewrite this in place of z star. We're going to rewrite this so z star is in place of t star and keeps the rest of the equation the same. So then this is going to be our formula for the margin of error. And let's fill this in. So we're going to have 2 equal to z star, and we're going to use z star for 90% confidence interval. And we can just use the function in our calculator, the inverse norm function. Going to distribution, inverse norm. This, remember, enter the area to the left. So if it's 90% confidence, that means you're going to have 10% left over, or 5% on each side, or 0.05 to the left. And you don't have to enter anything else, just enter this, and it's going to give you approximately the standard or the z-score that you would want. So about 1.645, you can say. So 1.645. And we're told to use the standard deviation to be 30. And that's going to be over the square root of n. So now it just becomes an algebra problem, which hopefully it's going to be hopefully that's the easy part. So multiplying both sides by the square root of n and dividing by 2 will give us the square root of n will be 1.645 times 30 all over 2. And then we just square this answer to get n. So let's leave this up to our calculator. So let's go 1.645 times 30 divided by 2, squaring that, and we'll get about 608.86. Now, we want to pick, a number that's big, that's going to be the next whole number bigger than this, because we're talking about people. You can't get 608.8 people, so you can get 609. So we're going to have D be our answer and not C. So the answer will be D. Number 9. Right here we got that telephone poll of a simple random sample of 1,234 adults found that 62% are generally satisfied with their lives. The announced margin of error for the poll is 3%. Does the margin of error account for the fact that some adults do not have telephones? Okay, so let's always keep in mind when just just because we're meeting certain conditions, random 10% large counts, we have to always take into account how the study was technically done, and there's always usually going to be some arguable bias and some issue. So just keep that in mind. Like, it's pretty hard to conduct a foolproof, study that has no arguable bias. Anyways, let's look at the first one. It says, yes, the margin of error includes all sources of error in the poll. This would not be correct, because again, it doesn't account for all errors in the poll. It accounts basically for randomization, but it accounts for the fact that we took a random sample. But there's issues with, what if it was a random sample, but not everyone responded. There would be something called non-response. So it's not going to be A. It's not going to be B or C, because again, it's not a simple random sample doesn't account for every type of bias. That's just going to be what you have to accept. And later statistics courses, you're going to learn more powerful methods to deal with that. But that's why it's called a simple random sample. Now D and E. So the margin of error includes non-response, but not under coverage for D. And E, it says the margin of error only includes sampling variability. So the answer is going to be E, because I think I already said earlier, this sample does not account for non-response, and it doesn't even really doesn't even mention anything about under coverage. It really just says that they took a simple random sample of 1234 and doesn't really announce or any other details. So the answer is going to be E. The margin of error only includes sampling variability. Now there's a lot more to this. I don't want to drag on and on with this explanation. So feel free to look back into that lesson where I introduced like some of the issues with conducting just random samples and and estimating population parameters. All right, and the last one, 10. The Census Bureau report on the income of Americans says that with 90% confidence, the median income of all U.S. households in a recent year was $57,005 with a margin of error of $742. This means that, okay, so remember what the confidence interval is. It's basically a range of values that we have some percent confidence, in this case, 90% confidence, that we believe will contain the population parameter. In this case, it'll be that we think will contain a population mean. So let's go through these. So 90% of all households had incomes in the range of 57. Nope, not 90% of all incomes, not 90% of all households, and that's not what we're talking about. That 90% doesn't have to do with the 90% confidence interval. So it's not A. B, it says we can be sure that the median income for all households in the country lies in we can't be sure. We cannot be sure. So that's the key word you want to be careful of. We cannot be sure. So it's not B. It's not A. C, 90% of the households in the sample interviewed by the Census Bureau had incomes in an interval. Again, it's not talking about 90% of the households, because that's not, I think these ones are trying to trick you, I guess. So it's not going to be C. D, the Census Bureau got the result, $57,005 plus or minus $742 using a method that will capture the true median income 90% of the time when used repeatedly. So this is going to be our answer. This is essentially like the definition of the confidence interval. And let's go over E, why it's not going to be E. 90% of all possible samples of this same size would result in the sample median that falls within 742. No, it doesn't. It doesn't get that specific. It's basically, you know, it's adding more details and more complexity than, you know, a composite interval does. So the answer is going to be D.